Welcome to InContext, the podcast by Blindata, the cloud platform to build and to govern the full life cycle of the enterprise information architecture. I'm Jacopo, the product owner of Blindata, and in each episode, together with Andrea and Gabriele, we'll explore how to enrich data with context to make it easier to understand, use, and combine, unlocking its full potential. If you want to learn more about Blindata, head over to our website, blindata.io, or sign up for our newsletter to stay in the loop. Now, without further ado, let's jump into today's episode and discover together how context changes everything. Hello everyone, I'm Jacopo and I'm here with Andrea and Gabriele. This is our fourth episode of Blindata in Context, and today we are going to talk about knowledge. In the latest episodes, we outlined an idea of a three-layered information architecture. We started discussing the importance of treating data as a product. Then we explore the evolution of the data catalog, introducing the need of a data products catalog with a marketplace on top in order to let data to be reused and to be composed. And today we are talking about the upper layer, that is the one of the knowledge plane. Just to break the ice, Andrea, can you introduce us? What is the knowledge plane? What is the meaning and the content for the organization?
Okay. The question is approachable at least, because I was scared that you were going to ask me what is knowledge, and there are hundreds of years of philosophers that discuss what is knowledge, and it's not an easy question to answer. No? But the knowledge plan is something that I can at least try to answer the question. Basically, the knowledge plane is a plane that in the information architecture sit on top the information plane that sit on top of the data plane. So we have the information architecture pyramids, and it's the third layer in these pyramids. Each layer basically add more context on data, making data more understandable and usable by the potential consumer. The knowledge plane basically is a model that describe in a formalized and shared way the key business entities and their relationship that characterize a specific business domain. So in the knowledge plan, we have this model, and this model try to model these key business entities that can be the customer, the warehouse, the production plant, the shop, and how these entities correlated. So are correlated to relationship like sell by, purchase by, ship by, and so we have this sort of graph of entity connected by relation. The important thing is this knowledge, this description contain the knowledge of the business and how the business domain is structured, is described in a formalized way. So it's not implicit or ambiguous description. It's a formalized description that is shared across all the companies. So when you describe in the conceptual model what is a customer, you are not trying to describe the customer in all its possible detail, but you try to find out what are the characteristics of the customer that are common to all your business division, to all your business unit, not something that is really specific of one business unit, but what is common across all your business domain, because this is the shared language that the company can use when needed to interact cross domain, when needed to share data cross domain. It's a unique definition. Maybe it's not the most complete one, but it's something that is shareable across the domain and guarantee the interoperability and facilitate the communication across the domain, because it's a sort of a common language of the company.
Yeah, and just to be clear about the objective, now in the other episode we've seen that every layer of our information architecture has as an objective. So the data plane, treating data as a product, the objective is to allow the scaling and allow the contability over our data. The information layer is designed to promote reuse and to promote the creation of value by composing different data products. Here in the knowledge plane, I see, of course, one first objective is the one I would say about giving a shared vocabulary, so giving a sort of documentation across all of the organization. And I'm asking to you if there is also some objectives from the data management perspective. There is some advantages in putting in place a knowledge plane when we are integrating data.
Yeah, yeah. In general, the most important one, why you need to have a common vocabulary, a common language within the company, as I said, because you want to facilitate the communication between the different part of the company that have not always to translate from one language to another language, for the language of the marketing domain to the language of the sales domain, but they have a common language that they can leverage to facilitate the communication, the interaction, and the coordination between the different parts across the company. And this is of course very important when it comes to data, no? Because you produce the data within the specific business domain, so you have the different data products that are managed with an alignment to the business, to the different business domains. So basically this product speaks the language of the domains, but because you can connect the data exposed by this data product to the semantic linking to the concept that you have commonly defined in this common language, that is the set of concept and a relationship with concept that constitute the conceptual model into the knowledge plane, you can basically bridge the semantic of the different domain and centralize this translation work. So I can specify that my product that contain data related to the customer, described as I like to describe this data within my domain, for example, within my sales domain, contains some information that are linked with the concept or property of the concept of the customer that we have sharely defined in our conceptual model. So for example, the field address of my customer data set exposed by my data product is actually the shipment address defined in our ontology. And if somewhere else there is another product that exposes the shipment address, this kind of information, and referentiate the attribute shipment address in the conceptual model, I know that I have two data sets that contain the same information, and I can join or combine it using this information. So it's more simple to make a product interoperable across different domains. And I don't mean only interoperable at the technical level, no? Because this is something that is guaranteed by the information layer and by the data product way of managing the data product. So basically data product have similar interfaces at the technological level, so it's very simple to put the data that come from different data product, even across domain, together at the technological level. But the existence of a knowledge plane and this conceptual model toward which all products can link their data guarantee also a kind of interoperability that is at the semantic level. No, I know that I can put together these two data sets, and in particular maybe do a union of these two fields because are the same, or these other two fields are not the same, so are not comparable in a way that I plan to do. And this is possible because all these different data sets referentiate or does not referentiate a concept in the shared ontology. So I say for guarantee semantic interoperability, that at the end mean to facilitate the reusability of data product, not only within the domain in which the data product has been created in the first place, but also across the company, across domain.
Thank you, Andrea. So let's talk now about the tools. So in the information layer episode, we started from the data catalog. We outlined why the data catalog is enough for building a data product centric data information architecture. So the question is here is to Gabriele, is the standard, the traditional, I would say, business glossaries enough to design and to maintain a knowledge layer of such type?
Yes, Jacopo. It's always an evolutionary journey, So most companies always start with a basic business glossary that is just a list of terms. And this is a simple dictionary, and its goal is to create a standardized vocabulary so everyone can agree on something like what an active customer mean, what a product mean, and so on. But the way it is used is primarily through tagging. So you just tag data assets with terms. But this is useful, but it's just a simple link. So then you need to answer the question what this data is about. And the next logical step is to organize this business glossary into a taxonomy by adding a hierarchy of terms, but just simple parent-child relationships. So, for example, an iPhone is a type of smartphone, and which is a type of an electronic good. This adds some structure to the glossary, but and improves classification and navigation. But the usage is still more intelligent form of tagging, but it's very rigid. So, but as you know, the business isn't just a hierarchy. You hit a wall when you need to capture how things are actually connected together. So the leap, so you need to build an ontology because you have the need to be more expressive, and an ontology is beyond the simple relationship of a taxonomy because it uses the semantic triples of subject, predicate, and object. So you with these three things you can model any kind of connection. For example, you can model like a customer purchases a product, and so on. And this changes how you use it because you move from simple tagging to a true knowledge graph. And so you are not just attaching label to a dataset, but you are creating an explicit link using semantic linking with a concept or an attribute. So and this in a machine readable form that can be also understood by things like agent and so agent can be context aware agents, and this is very very important.
Yeah. So Gabriele, we are moving from the traditional list of terms toward an approach that is more focused on relationship among objects, and we do that with ontology. Of course, the topic is very hot this day due to generative AI, agent, and so on. And in this field, all often we hear about, of course, about ontology, but we also talk about semantic layer. So the question here is, there is a difference between the two, and if there is a difference, which is the difference?
Yes. Let me say, from my perspective, the ontology is one way that you can use to organize and formalize the semantic layer. No, so the semantic layer. What is the semantic layer? Ideally, the semantic layer for me is another term that you can use to describe the knowledge plane. No, it's basically your information architecture pyramids. It's the layer in which you contextualize the data at hand through semantic. This is why it is called the semantic layer. No, while in the information layer you add basically technical metadata that enrich the context of the data that you are managing, turning this data and information in the knowledge plane through the semantic layer, that is basically the same thing. You add more context to this data through the semantic. But in general, unfortunately, in the data management field, there is not a central authority, or not unfortunately, maybe it's better like this, but there is not a central authority that define the terms and the vocabulary used by the community. No, so there is not an authoritative place in which you can go and say, okay, the semantic layer is this thing. So every player in the market can use this term with giving to this term a different meaning. So beware. For me, it's not a problem if a term is overloaded, specifically in a period of hype. What is important is the fact that when you listen to someone talking about semantic layer, you have to ask, what is your definition of semantic layer? Because I want to be sure that we are talking about the same thing or different thing. And then when you give a definition, you stick to that definition and we can have a communication. So basically, in the data management field does not exist an ontology that simplify our communication, and we need every time to ask what you mean with this term, do the translation so we can talk. In general, for what I see on the market right now, there is a sort of polarization. The most people that talk about semantic layer usually come from the business intelligence community. So a semantic layer for them is basically a layer that introduces semantic to facilitate business intelligence. So this semantic layer usually is not based on ontology, is based on a blueprint model, usually defined with the rule of dimensional design, in order to represent semantically your data in a dimensional model that is a sort of semantic layer that can be then easily manipulated by BI tool to aggregate data, drill down, slice, compose data across different dimensions over different measures. Okay, so usually most of the time when you listen the term semantic layer, you have a big chance that is something really related to business intelligence tool, adding semantic to business intelligence tool with a fixed structure, with a fixed semantic model that is designed upon the principle of dimensional design. Instead, when you listen to someone talking about ontology or a more general knowledge model, it's someone that is more related to the field of data management and facilitate the data management to create interoperability, especially now very popular in the context of agentic AI. So without a predefined conceptual model, with a predefined structure, but with an ontology in which you can, as Gabriele said, you can create your own structure as you prefer. Should not be necessarily a dimensional model, can be everything. Usually is a graph. Is a graph that once connected, when your ontology that is already a graph is connected to your data product in the underlying data plane, you create a knowledge graph. Usually this community prefer to talk about ontology layer, knowledge layer, and most of this effort is to make data interoperable, especially, as I said before, in the context of agentic AI.
Thank you, Andrea. So, so far we are talking about the need to have a general model, and apart from the tool, one can choose in the design choices. We are talking about a shared model, that usually is considered something very centralized, given in the hand of a sort of governance team and so on. And that sounds like to me like a sort of paradox, because in the latest episodes we are talking about a lot about decentralization of the development, decentralization of responsibilities, and today instead we are saying quite the opposite, in the sense that we have, yes, to distribute data, but we have to create some sort of shared central model that works across the organization. So here the next question is, we understood what is the knowledge plane, we understood the content and the tools about the designer knowledge plane, but now the question is how we handle and how we manage this knowledge plane to not create another monolith and another bottleneck at the knowledge layer.
Yes,
Yeah.
that's the normal question that comes to mind, no? Because we with the data mesh, with the popularization of the data mesh, of course, the pendulum between centralization and decentralization has been moved, shifted toward decentralization. So there is a lot of hype of decentralizing everything. Actually, I think that decentralization is not an absolute concept, it's a relative one. You have to decide how much you want to decentralize in order to reach the level of scaling that you want to have. But at the same time, you have to consider that decentralization has also a lot of organizational cost to keep everything work in a right way. So you do not want to centralize more than you need in terms of return of scalability. Otherwise, you are waste a lot of money to do this centralization with a minimum return of your investment. So centralization is not a black or white thing, is a gray thing in the middle, and you have to decide in which position of the centralization you want to put yourself according to your specific need in terms of scaling, because decentralization does not come for free, come with a big cost, no? And what is this cost? This cost is the fact that if you want to decentralize in order to scaling fast, you have to create an organizational machine underlying that is more complex, because you do not want to decentralizing, splitting the company in autonomous parts that are not able to interact, because the organization, the definition of organization is an entity composed by different parts that work together to reach a common purpose, not a part that work alone like an island without communicating or having any kind of interaction. But as more you decentralize, the more you decentralize, the more you have to keep some centralized structure to guarantee that the different parts can work still together while in autonomous way in order to fulfill the purpose of the organization. No? So something must be centralized, even in a very decentralized organization. Otherwise, the organization is not an organization. It's a composition of parts that never interact. No? And the more things you decentralize, the more carefully you need to manage what instead you want to centralize in order to guarantee this current world. And I think that the semantic part is definitely something that you want to centralize. The first thing, if I have independent part that need to talk together in order to cooperate in the attempt to reach some common purpose, the first thing is to set the semantic, to set the vocabulary, the language. This part speaks in order to communicate, in order to interact. Then you have to specify the contracts, so how they negotiate what they are doing, but that's another kind of stuff. But the semantic part is an important part. Of course, you say, but how we can create this common semantic part, because it's not something that exists. Of course, each different domain speak their own language, and this language exists because each business domain is composed by people that work together, and while working together, they develop their own language, the ubiquitous language of the domain. But there's not something that exists as the ubiquitous language of the company, the common company language. It's something that you have to create, no? And you say, okay, but if we centralize the creation of this language, and we will see how this can be possible, we have a very big bottleneck. So it's very important to have this common language, but the only way that we can implement this common language is in a centralized way. So the development of this language became a bottleneck. No, the company is more fast in creating new concept, a new idea, than the capability of the team, the centralized team that develop and share this common language, is to adapt this language to the new need of the business. And but if you stop and think a little bit, this is the same problem that we had in the past with the data, no? If there is only one team that manage all the data of the company in a centralized way, this is a problem, no? Because this team cannot scale, is slow, and we came out with the data mesh that have some principle, and these principles are very good, no? It's about distributing, but not just distributing, it's about federating. It's an operating model to manage something that is a shared common asset of the company in a federated way. So having some level of decentralization, but also some level of control and federation. And I think that what we can do to scale the knowledge management, that today have the same problem of scalability that data management had before the advent of data mesh, we can think how we can apply the same for principle of data mesh, not to data, but to the knowledge management. So treating knowledge not as a central monolithic ontology, but as a collection of knowledge products, so sub-ontology that can work together, but modularize the central ontology, aligning the development of this knowledge product to the knowledge domain, and we will see what is knowledge, what is a knowledge domain, having some kind of underlying platform that simplify the management of this knowledge product, and also define computational policies in order to validate that each knowledge product that maybe is created by a different group of people follow the central governance rule defined on how to create this knowledge model in order to guarantee the maximum interoperability between the knowledge products. So guarantee that each knowledge product, each sub-ontology is designed in a way that can fit with other ontologies in a common core enterprise ontology in order to form together like a pieces of a puzzle that can be put together in order to form the whole ontology that is not anymore a centralized monolith, but is a composition of different knowledge products developed by different teams.
Yeah, thank you, Andrea. I would ask you to just to get a little bit deeper about this concept. No? So it is clear that you are suggesting to use the same principle of data mesh to the knowledge layer, but there are also some differences. So the data is an asset, probably a technological asset, and we already know how to split data, but here you are suggesting the splitting knowledge, and I would ask you does it mean to split knowledge and to treat knowledge products. And the second question is, okay, we have also to apply knowledge domain orientation, so the second principle of the data mesh about knowledge, but practically what does it mean?
Yeah, let's call this approach basically the idea of applying the four key principle of data mesh not only to data but also to knowledge, and call it the knowledge mesh, no? Just to have this idea. So the four principle of data mesh apply to knowledge. This approach is the knowledge mesh. The most important thing to understand is the first two principles: knowledge as a product and the domain orientation in knowledge management. Let's start with the domain orientation in knowledge management. No? What is a domain in this case? When we come about knowledge, when we are talking about knowledge, the domain we are talking about is a knowledge domain that is very different from the business domain. No? Data products are aligned with business domains. Business domains basically replicate the structure, the organizational structure of the company. Usually, my rule of thumb is to have a business domain for each business capability instance. No? So you have a business domain that is the marketing. One business domain can be the marketing. One business domain can be the sales, or one business domain can be the sales in the Nordic department or in the EMEA department. So when you instantiate a business capability, sales, sales north, sales south, this organizational unit is a business domain. So a business domain is something that is mapped on an organizational unit that already have people, resources, financial resources, technologies, and so it's ready from day one to develop their own data product. No, you have not to change the organization to allocate the accountability of data product to the business domain, because behind the business domain there is a business unit, and the business unit is a composition of people, financial resources, technology. So they are ready to take care of this responsibility and start building product. Maybe they have not the skill to do that, but they have the resources to pay central IT to do that, or to pay an external partner to do that, so they can take maybe not the responsibility but the accountability of creating data product. This is not the case for knowledge domain, because knowledge domains are basically orthogonal to business domain, because in knowledge domain you want to represent a piece of knowledge that is used across different business domains. No? So for example, a business domains, just to make an example, can be the customer, or can be the production system, or can be the logistic system. No? All the knowledge related to what is a customer, all the knowledge related to how we produce manufacturing products in our plant, all the knowledge related to our logistics system. Okay, of course, this knowledge area contain business entity that are used across different business domains. The customer, the most classic example. Every business domains have some relation and work with the concept of customer. So it's not something that can be given as accountability to one specific business domains, but you want to gather persons from different business domain, create a virtual modeling group in which each business domain that work with the customer are represented, and this team of people create the shared definition of what is a customer that can be used then within each specific business domain. So knowledge domain are orthogonal to business domain, and people that do modeling within a knowledge domain usually are people that come from all the business domain that are interested in using and talking about this specific concept or the concept that belong to that specific knowledge domain. Everybody is represented, but it is a federated team. Is a federated team composed by persons that come from business domain that are interested to talk about that specific concept or collection of concepts that constitute the knowledge domain. This team then start to modeling this concept, and this concept form an ontology. For example, an ontology that defines what is a customer. There can be one concept in the ontology or more concepts related to the customer. Or in another knowledge domain, they can start to describe what is the production system or how the logistic process works, and start to describe this kind of ontology, very specific, very focused on the knowledge domain we have defined. And then this ontology basically is managed as a product, exactly as a product. So there is this team that is associated, this federated team that is associated to the design of this sub-ontology. There is an ontology owner. This ontology have a life cycle. These ontologies must respect some rules in the definition, some policies defined externally. So it's exactly as a data product, but it's not about data. It's about knowledge. It's about to create a product that does not share data, share an ontology. Basically, this is basically the idea about the first two principles of data mesh applied to knowledge, the ones that are more organizational one, no? Orientation toward domain. We are not talking about business domain, but here we are talking about knowledge domain, and managing data as a product. Here we are managing knowledge as a product. So a sub-ontology and ontology is not something given. It's something that have a life cycle. It's something that have a product manager. It's something that have a dedicated team around. It's something that must respect some policies, and so far and so forth.
So it is clear that it is not a splitting only in the concept, in the elements of the ontology, but is an organization of team, an organization of responsibilities. But as you said, this is the knowledge message. So the same that happened in the data layer happens in the knowledge layer. So
yes, but if I can add, here it's more difficult, because in a data mesh, the domain are associated to business unit. The business unit already exists in the company. Instead, if you want to create this federating modeling team that basically gather person that come from a different business domain, it's a modification in the operating model, in the organizational structure of the company. You have to create the resources for this team to work. You have saved the time for them to work, and so you have to create an extension of the organization as it is today. You have to extend the operating model. You have to find extra resources. So
exactly, Andrea. In fact, you must have a unified platform that allows to foster collaboration among people within teams. So the ontology can be built by different people in different domains easily, and as we said in the previous podcast, for the data catalog, the platform should offer an easy way to navigate and search for data asset, and in a similar manner, the platform should be the single entry point for accessing and navigating and also searching among the knowledge layer. So and this is very important. And also, as you said, there is a shift on how we build the knowledge layer, the ontologies. And also there is a shift on how the tagging of the data is made. So we don't have a centralized data stewards anymore, but instead we have domain experts that apply the semantic linking directly when they are creating data assets. And here is the shift left approach, where people who know the data, because they are directly managing it, are responsible for documenting and linking the data to the ontology. And also, as you said, the platform should also support computational policies. So you can also automate checks on semantic links. And this is very important because you can ensure that the data is always linked and documented correctly. So you have these features that put together and create an environment that offer a well-defined knowledge layer, and that is also connected to the information layer.
Yes,
Yeah.
let's say that you have to have a platform that helps you in building such processes in a seamless way. So far we have seen organizational principle. That we have talked about splitting in knowledge domains and treating knowledge as a product. You talked about platform capabilities. So the need to manage, share and exploring some sort of shared knowledge model across the organization, as well as some principle in building the links and with the other layers of data. So just to sum up and closing this episode for this webinar.
No, it's already finished.
Yeah, it's almost finished.
Okay.
But I think that this is probably the biggest question, and Andrea, and which is the final operating model that works on the knowledge layer and works on the data layer, and what is the resulting way of working by putting in place such approaches.
Oh, yeah. Okay, I think that when it comes to operating model, the operating model is like a clothes, so must be designed around the specific organization. So it's possible to have an operating model that fit every kind of organization, and even the same organization maybe because change over time, and so the operating model should be adapted over time. So it's impossible now to say, okay, this is the best model. But talking at a high level, I think that is very important, and nowadays more than ever, it's very important to have to design your own operating model, keeping the value generation in mind. So having an operating model that is value driven. And this is not an empty word. I mean, in order to create this kind of model, the first thing that you have to do is to sit down and define clearly what is a value. What is value for you? Value is not something that you can say we are working to produce value. What is value for you? What kind of value you want to produce? In which measure? And what are the consequences of creating this value? So if you want to have something that is driven by value, the first thing is clarify what is value. And usually for us, clarify what is value is define a clear set of goals, associate to each goal a measure of success. So we define value in terms of a set of measure of success, what we want to have an impact upon. This is what it's value for us, no? Of course, this measure of success can change for by organization. Every organization have different business strategy and translate this business strategy in a different set of measure of success. But without having a clear set of measure of success in place, it's not possible to organize activity and to have an operating model that is driven by value, because simply you do not know what is the value for you. It's a very generic concept. No, we live in a world of data management, and usually the strategy, what the business asks to the data team is, we want to become a data-driven company. This thing have no sense, no? You have to define what does it mean for you become a data-driven company, and you can do that only by specifying a set of measure of success. Once the measure of success are being put in place, the important thing is not to start working in a waterfall way on the construction of the information architecture, saying, okay, now in order to achieve these goals, to have an impact on this measure of success, the first thing that we have to do is to create the data platform, create all the most important data products. And then when we have the data products, we have to create the information layer, so put all the data products in the catalog, expose to the marketplace. And then when we have the marketplace, we have to create the shared ontology at the organizational level, and then we can put on top of that the use cases. Maybe some of these use cases is based on agentic AI. That's not the way that we want to proceed, no? In a waterfall, producing a result and having impact on our measure of success after a super long cycle of building the pyramids from the base to the top. Now we want to be more lean in our production system. So what we want to do is define the measure of success, define the use cases, the business use cases that have more impact on this measure of success, prioritize them according to their feasibility and the effort required to implement them, and then start to implement these use cases, but not in a way that all the work that you do behind the scene to support the use case is a byproduct of the use case, but you implement the use cases, start to creating the pieces of the information architecture that you need to support the use case, but implementing them in a way that this work can be reused also for a future use case. So implementing the data integration, using the data product approach, publishing the data product in the marketplace, create the piece of ontology that describe the data product, and create a set of artifacts that became asset used by the use case that you want to implement in the first place, because has been prioritized for business reason, has been prioritized in order to have a faster impact on my measure of success, but implementing it, creating all that asset that are reusable also for future use case. So basically building your information architecture a piece at time, and prioritize the pieces of the information architecture that you are building because of the use case that you have prioritized. In general, if we talk about the information plane and the knowledge plane, the idea is very simple. If you zoom out, no? The idea is, I have a use case. The first thing, when this use case has been prioritized, I need to understand what data are needed to implement the use case, and what concepts are correlated with the specific use case. And so you can start two streams that work in parallel. In one stream, you define the concepts that are involved in that use case, and on the other stream, you define the data product that feed the data to the use case. So you have some knowledge product on the upper stream, you have some data product on the on the bottom stream, and once you have finished all the data product that support the use case, all the concepts that describe the main entities related to the use case, you can correlate your data product produced by the bottom stream with the concept defined by the upper stream through the semantic linking, and you have built a slice, a small piece of your information architecture, of your knowledge graph, because as we have said, when you connect the data with the concept in the ontology to the semantic linking, you are creating a knowledge graph. You have created a piece of your knowledge graph graph that is needed to support the use cases, but then is an asset that can be reused for future use case and add value to your knowledge graph in general. So you do not build your information architecture or your knowledge graph if you want to represent the information architecture to a knowledge graph one layer at time, but you build it one slice at time, and what is contained in a vertical slice of your information architecture or your knowledge graph depends by the use cases that you have prioritized because of business reason.
Yeah, so Andrea, it is not a matter only
I spoke
of,
a lot, sorry, but because I want to reach at least 50 minutes, because it's the less for our podcast. We cannot go shorter than that. No?
No, Andrea, but it's fine. It's fine. No, I was saying that it is not a matter only of splitting the teams and creating the right teams, but it's also a matter of taking the leanest approach to building such an information architecture. So thank you for that's quite a long this discussion.
Also another thing is you it's a very complex way. It's very complex. It's a challenging topics, no, and probably you are not going to get it right from the start, no. You try to put in place a sort of an operating model to create data product, to create knowledge product, but probably will not the best from the beginning, and you have to modify it and adapt it a lot of time to your specific organization, maturity level, and your context basically. So what you want to do is to proceed in a lean way in order to learn while doing the process, no? And instead to say I move one layer, you want to reduce the risk and maximize the organizational learning through these short iterating cycles around data product, keeping always an eye on how are you impacting the measure of success, no? So avoid waterfall, avoid big investment in create a big complex operating model, in creating big complex ontology, but work one step at a time, driven by use cases, and learn from each iteration how you can improve the process.
Thank you, Andrea. So I would say that we can keep this podcast less than an hour. So we have reached the end, and guys, it's incredible, but we have talked about a semantic layer without talking about AI and agents. But I promise that.
And without talking about Blindata.
And without talking about Blindata, yeah.
Okay, but we give for granted that Blindata do everything that we have said in a fantastic way.
Exactly.
Yes, but this is the topic of the next episode, so we can also talk about how to use the knowledge layer once it's established. So thank you again. Thank you.
So we are going to talk about MCP server. Or something like that. Original. It's very original. Okay.
Thank you, Andrea. Thank you, Gabriele, and thank you for listening us. Remember to follow us on LinkedIn and YouTube, and see you next time.
See you next time. Thank you. Bye-bye.
Bye.
That's it for today's episode of InContext. We hope this gave you a clearer understanding of why enterprise information architecture and context matter more than ever. Thanks to Andrea and Gabriele for joining. Don't forget to subscribe, follow us on Spotify and YouTube, and visit our landing page for updates and bonus content. Until next time, stay curious and remember always to keep things in context.